Yeah, all welcome to today's talk. It's going to be by giant Kweku Asmah. But first of all, let me also welcome those joining us from Ghana, US, and Europe, and our chairman who is somewhere in Barbados.
It's in British Virgin Islands.
British Virgin Islands.
British Virgin Islands. Yeah, I think yes. Barbados sounds cool.
English.
Barbados sounds cooler than British Virgin Islands. So, you're all welcome. We would like you to, put on put the silent on your Zoom so that we don't get any background noise.
Don't forget to pray.
Yeah, we'll pray. And also, you can be typing in your questions as we go along. Yeah, maybe I should pray before I introduce the speaker. So let's pray. Lord, our Heavenly Father, we thank you so much for this talk. We pray that as we having a conversation with each other, we'll learn more and we'll help ourselves in our careers. We thank you also for the speaker. We pray that you deliver as he always delivers. We thank you for GSTS. We thank you for our union. Thank you for GAA. We pray that we'll grow from strength to strength. In Jesus' name, amen.
Amen. Amen.
Okay, today's speaker is giant Kweku Asmah. Kweku was born in Winneba. He's a Winneba boy, but he lived almost most of his life in Takoradi. He came to GSTS in Form 1 in 1982 and obtained his GCE, at the time was GCE O level, in 1987. At GSTS, I'm glad to say that he was in House 7, and he was also a day student. He went on to the Kwame Nkrumah University of Science and Technology, and he did BSc in Electrical and Electronic Engineering. Kweku, as I know him, is a very, very practical person. I know it's maybe because of GSTS, but he actually is one of the most practical engineers I've encountered during our school days, even in university. If you are looking for the best speakers to build, you go to Kweku. If you want to have a very, very loud speaker, you go and see him. So he's a very practical person. He's been doing these things, building amplifiers and all that, even when we were in school, and making a lot of money as well. So he went to NUST, and afterwards he started a small business that offered maintenance and repair works on computers and ATMs in Takoradi. In 1999, he joined Unilever Ghana Limited as an instrumentation and control manager, and he rose to be the electrical services manager. After a few years, he decided to go his private business. I think that's his main calling. And he's formed a Process and Plant Automation Limited, which is a thriving business in Ghana today. He's currently the CEO, and his clients include mining, oil and gas, energy, food and beverage, real estate industries. He's got an automation hub. His company's headquarters is in Accra. It's a solar-powered, smart building. And I'm sure he's a green man as well. He's green. Giant Asmah is happily married, man, and he's got a family that lives in Accra. He enjoys swimming, which I'm sure he began in GSTS, swimming to Kotasi. I'm sure he likes music and reading. And today he would be giving us a talk on his expertise and educate us on automation and control systems. So over to you, Kweku.
Thank you. Thank you. Can you hear me?
Yes.
Right, good. So good evening, all of you. Good evening, fellow giants. I'm honored to be called to deliver this. I'm told this should be 30 to 45 minutes. I'll try and stay within that. So I would start by defining automation and trying to bring to mind why the need for automation. It drives sustainability and growth. And today, from the smallest borehole you can find anywhere in the world to the most complex oil rig, automation is possible and is being employed. And indeed, there are certain projects that you undertake that if you don't automate, you don't even start because it just too enormous a task to try to do manual stuff. It drives quality and eliminates human error, and it drives your costs down. You know, it reduces losses due to human error, negligence, and it optimizes whatever you do. So whether it's raw material or use of electricity or use of water, once you know what you want and you know the key drivers of your costs, you can always optimize it. If you know key drivers of efficiency or effectiveness or throughput, once you know these and you tell an automation engineer, he should be able to optimize your process for you. So it's something that I encourage everybody to look into. Just, you know, thinking out of the box, how can I improve this thing that I've been struggling with? An automation engineer should be able to help. Now you save time, increase productivity, and eliminate unplanned downtime. And this is for the fact that these days, routine maintenance and scheduled maintenance is outdated. We do predictive maintenance, and predictive maintenance, obviously, you need some level of artificial intelligence. And I'll talk a bit about it later on. And then enhance security. You can use automation to enhance your security of assets and people. These days, you can track anything, including human beings. So, yeah. And then convenience, of course. So this evening, we'll be talking about how automation is utilized in the mine. I'll just take a bit of the mining process and talk about it. I'll talk about terminal management, particularly for fuel tank farms. I'll talk about the manufacturing process in general, and I'll zoom in into soap manufacturing, how automation is employed in the soap manufacturing process. Then I'll mention something on batching processes as well. Then we would go into smart homes and then commercial buildings or buildings in general, how you can employ automation in such properties. Now to the mining process. The diagram I have up there indicates a truck that is tipping ore. And this is, if you like, in Ghana, it's gold ore, right? You go crash, you dig, you load into a dump truck. Dump truck goes to tip into a hopper. And then you have a hopper that now vibrates and sieves the gratings in terms of the granules that are coming. So the smaller ones will drop onto a conveyor. Conveyor then transports it into the crusher, which is a mill, a drum, okay, on the far right. But if you look at the drawing, you'll see that there's another conveyor on top of the long one. And that conveyor takes on the bigger aggregates that are not able to go through the screen. And it goes into a second hopper, which then crushes them into smaller, aggregates, and then it is transported further and it drops back on the the longer conveyor. Now, this process could be driven by a conveyor belt and just motors, and it goes into the drum. But what if the drum fills up faster than it being emptied? There will be a backflow. And so you know that the ore would pile up on the conveyor. The conveyor would have to overcome the extra load, and then the motors would stall and stop and trip, and production stops. And this is where automation comes in. So you are looking at how you can synchronize the speed of the dump truck, the rate at which dump trucks come in, and use to determine the rate at which the conveyor belt moves, and then use to control the speed of the mill, and then the level inside the mill and the level outside of the mill. In other words, as the mill crashes and it discharges into a storage area, you want the rate at which this goes into the storage area to synchronize with the feed. And you need sensors to do this. And so a typical mine would have encoders, and encoders are small sensors that check the rotation of any device. And so the encoder will be checking the speed of the conveyor belt. You would have a level sensor inside the secondary crusher, checking that the secondary crusher doesn't empty or overflow. And as it fills up beyond a certain maximum level, we have what we call the variable speed drive that reduces the speed of the in-feed conveyor automatically. And then that signals the gate on the initial primary crusher. You know, the primary crusher has a gate. Usually we call it diverter or a damper. So it sort of shuts the gates a little bit to reduce the rate at which the ore drops on the conveyor belt, and then the top hopper will fill up, and the truck driver obviously will be signaled to slow down. As production increases, the speed of the mill increases, the conveyor belt now speeds up, and then the secondary crusher now speeds up. It signals the in-feed conveyor to speed up, and then more trucks can dump. Now, these are sensors that we place on the production line to pick information. Now, there's a code or a computer program that is written with predefined conditions. That is what I've described. And then it feeds into this computer. The computer runs the code, and then it outputs whatever it has to do to the motors, etc., etc. So just some notes that I would want to talk about. We monitor the rate of production, and so you can easily sit somewhere and tap into the crusher and check how much ore is being crushed and milled for processing. Continuously monitor dust buildup. Dust buildup is a consequence of production, and you can't avoid it. But you need to monitor such that it doesn't overbuild to stop your process. And so we have sensors that detect the inner lining of the drum to signal that, look, there's overbuild of dust. And so you shut down and scrape the mill, the drum. You actively monitor motor performance. The picture on the left has a typical drum with its motor. The motor is what you see towards us with the belts. I mean, you see some cylindrical something there with those belts. That is the motor. Typically, this will be a 1 megawatt motor. It can power about 500 homes in the UK, for example. Now, this, and I'm talking 500 middle class homes. So it's such a huge motor that if the motor fails, the whole plant will be down, and this can take them out of production for over a month. And so a motor like this has to be monitored 24/7. Bearings on the motors are fitted with temperature sensors and vibration sensors to ensure that nothing goes wrong. It monitors the health of the motor, monitors the temperature of the windings, monitors the current being drawn, monitors harmonics, whatever it is that can be monitored on the motor is being monitored. There is a cooling oil that circulates around the shaft of this motor, the coupling between the drum itself and the motor. And that oil is monitored. Actually, the flow of the oil is monitored. The pressure of the oil is monitored. And all this is computerized. And so it sends signals whilst the crushing process is going on. And you can imagine a mine in Ghana, for example, Goldfields or Newmont, Ghana, starts in January, and this mill never goes down. It runs probably for 6 months. They shut it down for 24 hours and start it up again. And so monitoring is key, and there is no way a human being can monitor this. So you actually employ automation in something like that. And then another thing is that as you crush the ore, you need to add water. Now, how much water you add will determine how much chemicals you would use to extract your gold, for example. So you need to monitor the amount of water versus the amount of soil stones, all of that mixture with the gold inside. And this is the pre-extraction stage. So you find that you need to find a way to determine how much water is in there. And when you pour water on the ground, you know that it dries up quickly, so it gets absorbed. So the method employed is radiometric measurement, which is more like a gamma process, using radiometry to do that. So it's quite dangerous, but technology has made it safe. And so we have very solid lead housing for these things. And that is what is used to check the density of the slurry that is produced. And that is also monitored, and it's monitored by a computer again. The next topic I'll talk about is fuel terminal management. And this is a typical fuel tank farm. If you go to any airports around the world, you would see there's a fuel tank farm. If you go to every port, seaport in Ghana, in Africa, in the world, you would see a fuel tank farm. And it's such a critical asset, and there's the need for automation in such facilities. I mean, as a minimum, there should be what we call the overflow prevention system, because as soon as you have fuel spillage, you have a disaster. And so as a minimum, if you would not automate at all, there should be the overflow prevention system. And how does this work? You install sensors on top of the tank, and they detect the presence of liquid and signal the pump that is filling it to stop, raises a siren, sends messages out there for everybody to be alert that this is what's happening. Usually we have 3 levels. We have high level, we have high level, and we have a dead level. This is the level where you must never get. And for most of the installations, you find that that particular sensor at the very top never gets to see fuel, because the other 2 are more like a redundant system. The notes I have here is that you use such a system or a setup to manage filling and emptying of fuel into ships and trains and aircrafts, etc., etc. On such a system, you have so many devices. And again, I'll talk about sensors. You have flow, level, temperature, and pressure sensors on such fuel lines. And why do you need that? You need flow to check the quantity that you're selling. You need temperature to compensate for volume losses due to temperature rise and the fact that temperature affects the volume of liquids. You need a pressure to determine safe operating limits, and you need the level sensors to check how much you have in the storage tanks. And so these are primary sensors that go with automation. There is no way you can have effective automation in a typical fuel tank farm without these 4 sensors. And so our job as automation engineers requires us to understand the way these sensors work. So these pictures you have here are 2 typical fuel tank farms. The one on my right is obviously not Ghana. That is a picture I picked from Rotterdam. This is at the Rotterdam port. And in there, you would have a typical control room where, you know, they get to see what they have and the activities going on in there. There is ship-to-tank transfer possibilities, tank-to-tank transfer. So within the tank farm, you can actually send fuel from one tank to the other. They also do additive injection. You know, oil marketing companies sell fuel in different grades. So for example, Shell has V-Power and they have the premium. And this additive injection is a calculated batching system that they use to inject the additive, because over-injection obviously will send the octane level of fuel to unacceptable levels. And then under-injection obviously will cheat the customer. And so these systems are designed to ensure precision, and so on and so forth. I mean, in a typical tank farm, there will be several reports, and I'll go through the notes. So we monitor fuel levels. So tank level gauges report on the amount or quantity of fuel they have per unit time. So, you know, at any point in time, you would know how much you have. And then stock reports are sent. Typically, we do it at midnight. So at midnight, reports are sent and a date and time stamped. Inter-tank transfer activity, as I said, tank gauging at any point in time, temperature, pressure, overfill prevention, flow detection and monitoring, and density as well. And then most importantly, leak detection. Now, leak detection is another big thing. Besides the fact that you lose fuel and therefore losing money, polluting the environment is one thing, and then the risk of fire. So leak detection in a typical tank farm is crucial. And you also don't want rainwater to flood the place and have droplets of fuel floating on the water. If I don't know whether you remember June 3rd fire at Kwame Nkrumah Circle some time ago, I think 2013 or so. Flood waters entered a fuel storage tank. The fuel floated on the water and transferred fire across the whole area.
Wow.
So with these things at a fuel tank farm, you want to measure the amount of oil on water, and we have special sensors to detect this. So you would have water in volumes, but we ignore the water and are interested in the fuel on top of it, because you need to be able to detect it and trap it and prevent it from going out. And that's something that we use instruments to detect. The picture on the left bottom is in Ghana. It's one of the fuel depots called Chase Petroleum. The next thing I'll talk about is the batching process. So typically, if you want to prepare gari soakings, you would take water, take milk, and add some sugar and add some gari, and then you stir. So the picture you have on the left is a typical basic batching system where you have 2 liquids being introduced into a tank. There's a stirrer, and then you mix, and then you discharge. You see that on the tank, there are 2 sensors, sensor 1 and sensor 2. They are detecting the level. So for the batch to start, both sensors should see nothing. So the operator can push the start button, and if the program has been written properly, a pump will start. So liquid A, maybe the recipe is throw in 10 liters. Liquid B, recipe says 20 liters. So those ratios would have to go in. But how does it go in? Valve 1, valve X0 would have to open. And then valve X1 would have to open. But as they open, how do you know the quantity? You need a flow meter on each of the lines to measure the 10 liters and the 20 liters respectively. And when they execute the 10 and the 20 respectively, a command has to shut the valves. Now, when that is shut, based on the reaction that will happen in the tank. So if you add palm oil and caustic soda, as soon as you introduce the two, you would have soap and it will kick in the tank. So you need to start your stirrer first before you start introducing. And you must introduce the palm oil first and introduce the caustic soda second. If you mix them without stirring, you would have a paste that is not homogeneous and you will struggle. So you spend more energy. Now, this is where process engineers come in.
That's where we come in. That's where we come in, right?
So those of you who studied chemical engineering,
that's right.
We rely a lot on you guys to give us how fluids and particles interact, for us to write the code. Fortunately for us, but unfortunately, we have to learn the process before we can code. And so, and that's typical batch control system. The one on the right is similar, but here, you can afford to use a load cell on the resultant tank to know what you have produced. The first one on the left doesn't have a load cell, and so you assume that the flow meters are right. But for a very precision process, you need to have both to be able to determine what you are producing. Because remember, if you have to produce something within some tight quality standards, you need to make sure your measurements are right. Sensors would have to be calibrated every now and then to ensure that they are giving you some consistency. The next one is tank inventory management, which is part of the terminal automation system. But typically, you would have the tank, and the tank would have sensors mounted on them. So you would see that on the diagram on the right, you would see an average temperature probe. We say average temperature probe because it's a long rod that is inserted from the top and it goes right to the bottom. And on a typical tank, say the tank is a 12-meter tank, you would have about 10 temperature sensors equally spaced from bottom to top. And so we measure at each point and average it. We are also able to use the level sensor on the tank to determine where the level is, and we ignore the sensors above the liquid. And so if the tank is half full, for example, 5 sensors will be used. The 5 bottom sensors will be used to determine the temperature of the liquid. In the past, the temperature sensors would be inserted at the side of the tank, and you have only one point. And so you find that the top of the tank or the top part of the fluid would have a different temperature from the bottom part, and accuracy issues come in. So so we have the average temperature probe, and then we have the level gauge. This level gauge we have here, the typical one you see here is called a pro servo. It works by dropping a ball using a servo motor, and it stops using buoyancy. So as soon as it hits the liquid, it sends a signal and it's computed. But the tank, before you commission the tank, has to be calibrated and mapped. And so we know that 1 meter above ground is so and so volume and all of that. And this mapping table is put into the computer to do the computations. So Let me see what I haven't talked about. All right. So in Europe, fuel depots like these report in mass. In the past, it was reported in volume, and temperature issues always caused losses. I mean, people could change figures and attribute it to temperature changes. But since mass is not affected by temperature effects, now internationally, every fuel depot is reporting in mass. In Ghana, the law has been passed and implementation has started. So very soon, that will also be effective here in Ghana. That requires every fuel depot to install temperature sensors and do some computations using the density of the product. And these days, there are instruments that can even measure density directly. So it makes it easier to determine the mass of the liquid. And so there will be no issues with truck drivers trying to falsify weigh bills. All right, so in a typical industry, you would find that you need to heat a process or mix something or fill something or measure or produce or count or clean or check or pack or dry or store or weigh something. Now, all of these require some primary inputs, and these are where we come in. So if, for example, you need to heat milk, all right? There are several forms of heating. So you can heat with steam, or you can heat with electricity, or heat with hot water. Now, how you control these, use the same principle. You create a PID loop. And so you measure, and then you heat and you measure and you control. You heat, you measure, you control. You heat. How fast you are able to cycle through this determines how accurate your figures or your heating would be. Mixing, same thing. As you mix, you check in. If you mix in two fluids and it is possible to check the turbidity, there's a turbidity sensor that we use to check how homogeneous your mix is. If you fill in, obviously we have level sensors and volume determining devices that we use to do the filling. You would measure flow, of course, you measure pressure, temperature, and level, etc., etc. We also have sensors to do counting, drying. We check temperature and humidity and all of that. Now, if you look at the diagram I have on the screen, you see that on the left is the process control system. In the middle, we have the manufacturing executing systems. And then you have the manufacturing management system on the right. And basically, automation cuts across all these areas. So you see that we do high-level programming at one stage, machine-level programming at another stage, database coding guys come in to do the manufacturing management systems where you are checking how efficient you are meeting your customers' needs. Orders come into factory, say head office pushes the stuff to factory takes up manufacturing manager and maintenance manager, plan the production schedule vis-a-vis maintenance schedule, etc. So in all of this, you find that as we get complicated, as production demands go higher, there's a need to automate, and you find them everywhere. If you are producing soap and you are producing at home, you probably will be doing 100 tablets a day, and that will be one man high speed, right? There are soap cutting machines today that can do 24,000 tablets an hour. There is no way you choose not to automate to be able to achieve such numbers, and you cannot compete in today's world with somebody who has an automated soap manufacturing plant that can churn out 24,000 tablets in 1 hour. So Ghana as a country requires to switch to automation to be able to stay competitive. Otherwise, the gap will continue to widen. So how do we achieve all of this? We will achieve this with having what we call the PLC. The PLC is a programmable logic controller. And what I've been talking about, computer, since we started, it's all about using the programmable logic controller. That's the image you see in the middle. On the left are the inputs, which basically are the sensors. And on the right are the outputs, which would be lamps, solenoids, motors, contactors, all the things that drive the real action. And so inputs check the condition. The PLC runs the code and sets the outputs, and the outputs do the job. And then inputs will pick feedback as to whether it's doing the right job, and the cycle continues. And that's basically how automation in industry happens. So that's a typical PLC panel. On the left is a typical PLC from Allen Bradley. It's a US brand. This is a very famous PLC, one of the most powerful you will find. On the right are two electrical cabinets. In there are PLCs from Siemens. Siemens is the European giant when it comes to PLCs. And so typically in a factory, this is what you would see in control rooms. This is where all the logic happens. And then you have your cables going to the field devices. And PLCs use standard language. IEC 61131 is what we use. And there are 5 different languages. And so it's international. I mean, if I meet a Chinese PLC and I'm able to connect to it, this is what you see. You won't see Chinese language. So it makes it easy for you to work everywhere. A moment. All right. So these are some of the input devices that we typically use. Pilot lamps, encoders, selector switches, push buttons, proximity sensors, and then some output devices as well. There are several, I just picked a few, but we need to know how they work, how they behave, and how they react to the environment. For example, the proximity sensor, you see there can only detect metals. And so if you have a milk tin, for example, and you want to count, this is the sensor you would use to count it. If you have a plastic bottle water like Voltic and you want to count it, you probably require a diffuse sensor that may look like this, but will not be able to detect other things. There are other sensors, I mean, numerous types using different principles. And interestingly, all these principles we studied at DSTS, but there was no link at the time. But from where I sit today, I realized that a lot of these things were in the physics books that we used.
Yeah.
All right. So in industry, about 80% of prime movers in industry are motors. So, I mean, motors consume from 40 to about 70% of the energy used in a typical industry. If you want to move products from one point to the other, it's a motor. If you even want to use a pneumatic conveyor, it's a motor that will drive the compressor to charge the air. So motors are so important in industry, and you've got to know them inside out if you want to use it to drive stuff. For example, if you are driving a viscous fluid, the motor you choose will not be the same as, or the sizing of the motor you choose will not be the same as possibly using the motor to drive air or compressors or water. But the amount of energy you need to kickstart a motor is quite high. And so technology has brought about other means. In the past, we were using standard switches, so direct online starters or star delta starters were used, which consume quite a bit of energy. A startup are not able to regulate the inrush currents that motors consume. So the picture you have on the right is showing typically variable speed drives that are used today. And they are very energy efficient units that allows you to manage the amount of energy that goes into the motors. And we are able to communicate with these devices. They are smart devices, so we are able to control them, change their speed, change their torque, change the voltage that goes to the motor, etc., to optimize the process. So, a typical factory that's not using a variable speed drive will probably be using 110 or 120% more energy than one that is using a variable speed drive. This is actually the technology used in electric trains, and today it's being used in electric cars as well. It's the same technology that is being applied here. So a typical motor control center would have variable speed drives and direct online starters, circuit breakers and contactors and all of that. But for an automated industry, you would have some feedback from the way they are behaving that assists people, maintenance managers and engineers in times of troubleshooting. So yeah, typically this is what you would see. This is not the same as the PLC panel I showed earlier. The PLC panel does the logic. That's where the brain is. That's where the control is. The motor control center is the one that drives all the motors. So that is where the big power sits. Then you have a typical finishing line where, for example, this is a process for cutting sheets. We call it cut to length. And typically you would have a motor. You see 3 cylinders on the conveyor. The one on top is the motor. It drives the paper, but it's in touch with the lower cylinder. And that lower cylinder is called a pull roll. And so the gap between the 2 rolls or the 2 rollers is where the paper passes. Now, the cylinder on the left has what we call the encoder, right? And that actually measures the speed of the paper. So the encoder sends its signals to the controller, and the controller determines the length that has traveled over the surface. And the knife on the top roller, which is the motor side, would cut the paper. And so, nobody uses a tape measure to measure the length before it's cut. The encoder does the job. And so as soon as the encoder counts a certain number of pulses, the controller sends a command to the knife to strike. And that's how we are able to cut stuff to length. And it's a very common process, and I'll show you when we get to the soap making side. These are typically sensors that used to be around, but they are all obsolete now. In the past, we were using bimetallic strip temperatures, temperature sensors, etc. Today, we are using PT100s, that is platinum sensors, and they look like what you have in the middle. The picture on the left shows top of a fuel storage tank with a level transmitter or level sensor with some technicians working on it. So that blue thing you see there is what measures the level of fuel in a typical tank. And it's this is a radar type radar type level sensor. It sends electromagnetic waves down to the level. It hits the top of the level of the liquid and reflects back. And the time it takes to travel to the level and back is used to calculate. And this uses the good old equation for speed of light to compute the length. So that's basically what it is. And then pressure gauges are still used, but they are only for indication. But this is the type we use for automation. These are the same pressure sensors, but these are able to talk to computers. So we have communication cables going to them, and they send real-time information for us to compute and take decisions. So that's a typical radar level sensor mounted on top with an antenna sticking inside the tank. It sends an electromagnetic wave down, and then it reflects, and the antenna picks it, and the computation is done, and the real value sense goes to the computer. The pictures you see here are typical flow meters, and this is flow meters without moving parts. It's a straight tube or a curved tube. It oscillates and uses Coriolis principle to measure flow. These are the flow meters that can measure directly in mass. And this is what is recommended for what we call custody transfer. Custody transfer basically is when you are transferring liquid for exchange with money, you must do what we call custody transfer. It is certified and it is acceptable to trade using this type of meter. Any other meter that's not certified for custody transfer could have errors, and you either cheat the buyer or cheat the seller. So this is the type of meters that is recommended today worldwide. And then how you install the meter is also crucial. I mean, I'm not going to go into the details, but this is just typical that, you know, you cannot install a flow meter with a fluid pointing down. It has to climb up because we always work with a fully filled pipe for you to be able to measure accurately. And so if the pipe is not full, you may not get it right. And that is where you need to engage a professional to do your installation works. I have a short video for baggage handling. This presentation is becoming quite long. Are you able to see?
Yes, I am able to see. This is exactly what my company does, what we do.
Oh, okay.
Baggage handling, yes.
So basically, typically a baggage handling, automated baggage handling system would check several things, but it starts when the traveler drops his bag. You know, and a barcode is stuck on the bag, and a barcode has so much information, and that barcode is scanned along the conveyor belts throughout until it gets on board the aircraft. Now, a highly automated baggage handling system would have typical diverters. Diverters, you have horizontal diverters that would take you through different gates, or tilting diverters that would take you to other floors. Or, for example, if you are a transit traveler, you know, the pre-arrival information is keyed into the system automatically, and your bag goes to your next connecting gate. All this is software-based, and once it executes, the outputs that need to get onto the field to control motors and diverters and actuators all go in there and gets this thing beautifully done. At the end of the day, the passenger travels in style and has no idea what's going on within the electrical panels in there. But it's all about gathering information from the barcode. That barcode has everything that it needs to have for the baggage handling system to work. In some cases, you have security scanners embedded as part of the system. You also have weightometers, or the weights that are measured at check-in are all put together to determine the weight of the bag and which compartment in the cargo hold of the aircraft you should go, because those who load the aircraft need to balance the weights properly. And all this information is put together using data from systems like this. So a lot of work goes into building such systems. Just to give you an idea of the kind of work we do.
Yes.
And then another one is I would want to show something interesting about soap making. So here you have, I'll just stop it. Okay, so you see that there are gaps somewhere, and other places the soap tablets are touching each other. Now, the gaps you have on your right are gaps that must be there to synchronize with the wrapper. At that point, the tablets are getting into the wrapper, and sensors on the line determine where they should be. And there are some stoppers that will stop it to make sure it is synchronized with the wrapper. Otherwise, the label on the wrapper, for example, if it's Lux soap, will not be centered on the soap. So when you buy it, you will not be able to read what the label is. And that happens using sensors that are able to position the tablets on the conveyor. And then the gaps on the other side, let's just okay, let me play this one. It's in this other video, so we'll go through this one. So the black line, is it black hole? The black line on the wrapper is the eye mark. So the sensor looks out for that eye mark, and the gap between that one and the next one is what determines this eye mark, and that one is what determines where the soap should meet the wrapper. And so when we are synchronizing, we need to make sure that we count the pulses between those two marks to set how the soap enters the wrapper. This is a flow wrapper. What it means is that the wrapper would be turned into, will be rolled into a cylinder for the soap to enter. And then a rotary knife would come in to cut the wrapper and split it. So basically that's how it works. But on this line, there are so many sensors. There are proximity sensors, there are color diffuse sensors, there are retroflective sensors, there are encoders, there are temperature sensors, That's the rotary cutter. The rotary cutter is also synchronized with the wrapper. So basically, that's how we do the. And then there's one last thing about the packaging. So packing, that arm, robotic arm you see there has vacuum nozzles. And so it drops on it, it engages the vacuum and sucks the tablet and lifts it and drops it. And each one is timed accurately such that it picks all of that at the same time. If one nozzle fails, the box will not be filled properly. And that is also monitored. Let's move to Smarthome. Enough of industry. Okay, so Smarthome is now redefining the way we live. And obviously driven by IoT, the changes are very, very fast. Development is very, very fast. And every day there's a new product. So a Smarthome is a home in which devices can talk to each other. So your lights can talk to your TV, and your curtain can talk to your phone, etc., etc. You can control things locally or remotely. It doesn't matter where you are, as long as you have the internet, you can, talk to devices. And these days, you can also talk to them. I mean, talk through some of these voice-activated gadgets that are all over the place. So you can control gates, garage doors, ceiling fans, sound systems, sockets, cooker. I mean, just name it. And devices are becoming smarter and smarter. All this is based on the basic automation that, industry players have been using since Second World War. But obviously, the internet has changed things, and it's making things move very fast. Now, the benefits. You save cost if you have a smart home because, you can determine how energy is consumed. Convenience, obviously guaranteed. You don't need to get up to go and do anything. Obviously, it makes you lazy, but entertainment. I mean, some people have smart homes where, you can actually turn the ambience surrounding by just clicking a button for all your lights move from white to red to yellow to blue, and set up a theater and have a beautiful night jam. There's also security that is integrated. So this time you don't only have a security or intrusion detection system, but it's integrated into the entire house, such that, you tell Alexa you are leaving home, and Alexa arms your security system. If there's an intruder, cameras take pictures or videos and sends them to you on WhatsApp and things like that. So the integration also makes it quite convenient. So let's talk about some of the applications. So motion sensors and smart switches can be used, implementing time of day lighting. So if it's during the day, obviously, if you leave your lights on, the lights will switch off, depending on what routine you have set. You can also use lux sensors to determine whether you need the lighting or not. You can also use motorized blinds to open and shut your windows and curtains. And then air conditioning. We use the same sensors that controls your TV to control your air conditioner. And so you don't need to buy any special air conditioner anymore. We just pick any type of air conditioner and we can automatically control it from your smart home. And these are some of the devices you will find around. Most of them are using standard protocols, so it makes it easy to integrate. A typical window with an actuator. So if you want the window to open every hour to bring in fresh air, why not? All you need to do is to configure it, and it does that for you. Door sensors and window sensors, as I said. Water level sensor on the right, and a water valve, automatic water valve as well. So, you can actually control. So when you are not home, Alexa shuts, or the smart home system shuts all your water lines. So there is no way you can even have your home flooding. Yeah, so I've talked about these. The ambient lighting, if you use a smart light that has multiple colors, you can also change your mood at any point in time and have different. So you say set illumination level and hue to corridor, indoor ambience. Obviously, depending on what you're doing at any point in time, or you can pre-configure them for lights to dim when it doesn't see motion. So you don't want to turn off the lights completely, but you want some pilot lamp or illumination around. And then different modes: party time, movie time, quiet time, sleep time, away time. All of these can be pre-configured into your smart home. So they do that automatically. And that also would actually trick neighbors to think that you are in. Meanwhile, you probably will be away. Yeah, so basically, I think that brings us to the end of, okay, examples of routines. Wake up alarm. So it will go through a routine like this: turn on lights indoors, open blinds and curtains, play music or tune to your favorite radio station, turn on water heater for 15 minutes, etc., etc. So all these are pre-configured conditions based on your lifestyle. It can be configured for you to enjoy.
Nice. That's wonderful.
Yeah, and then you've got virtual assistants, as I said, Alexa.
Yeah, we need to change Alexa to Kweku, don't we?
All right, so some of the routines. Good morning, Alexa. Alexa will take you through these steps. It will just do them automatically. Open curtains and turn on lights, etc., etc. Everything that you've pre-configured. Good night. It will take you through. Arm the intruder alarm. Disable motion sensor in the bedroom. Set the temperature to a convenient temperature for you. All of that. Leaving for work, it was just start and execute the routine. You don't want to go check every door, etc. Alexa will tell you that the back door is still unlocked. Things like that. And then the interesting one is the toilet. That does everything for you. That's an outdoor speaker. Now the future. So it started already, but not as common. I've seen it in China, where food labels have NFC tags that allows your smart fridge to tell you when foodstuff would expire, for example. So once you buy these food products, milk, whatever it is, put it in your fridge. Your fridge is checking when it's going to expire and all of that. If things like that. So in the future, things would get smarter and smarter. You can actually have your own NFC tags, put them on labels that would time when you place them in, and so it would say, look, you placed this thing in 2 days ago, you better take it out, etc., etc. So this is going to be quite interesting as we move along. Yeah, so who needs a smart home? Landlords, obviously. Hotel owners, to be able to determine and optimize the costs that is used, whatever expenses that is going into the running of the hotel, etc. We are able to also determine devices that are faulty before they actually get reported. Now for commercial, I think I've spent 1 hour already, right?
Yeah.
Yeah. So I would just go through this quickly. Building management system. Obviously, it's about determining the state of devices in the building. So we're monitoring air conditioning, fire system, security, surveillance, intrusion detection, etc., water management, and all of that. It's similar to industry. It's just that this is applicable to buildings. You would have a typical application using the following devices: actuators, as I said, variable speed drive for lifts, water sensors, just as we have for homes. And a typical screen. This is one project that we did here in Ghana, and within the facility manager has this dashboard and is able to tell where the lifts are. In this building, there are 8 lifts, and it tells you where each of them is at any point in time. It gives you temperature at any point in time, it gives you water level, fuel level. On the right side, you can see there is no flood yet, etc. So this is a typical building management or building automation screen. We did another one for a hospital where they wanted to monitor the waste shredder, and that's the typical screen. And this is for a basement car park where we are monitoring presence, number of vehicles, and also carbon monoxide monitoring. Yeah, these are SMS messages from a typical power station. You know, so power goes up and it sends SMS to whoever. For critical power stations, this is typically what we do, so that people can react before systems start shutting down. Yeah. This actually for a power station for a data center. So obviously a data center never goes down, right? So a typical alarm screen where it tells you garden pump power, it gives you time and date and what the issue is. So whoever is in charge of maintenance can actually react to it before things get out of hand. And then we trend as well. So this is a typical energy report. And yeah, typical energy report. So you can actually tell how much energy you are consuming and at what time it peaks and all of that. Of course, there are challenges in Ghana as far as building management is concerned. You know, the knowledge is still low. People don't believe that Ghanaians can do this and can maintain this. And so we always have to talk and talk and talk. Right. So that brings me to the end of the 1 hour and 5 minutes presentation.
Well done. I gave you 35 to 40 minutes, you know. Well done. I'm so glad. I'm so excited that you've made time particularly when I said, "Oh, can you give us a talk?" You didn't even give me any excuse. Right away, you said yes. So I'm really glad. We'll go into questions, but before then, can I just probably just say this? Let me share this on the screen. Hold on. And then we come back to the questions. Yeah.
I have only one question, Ray.
But hold on. Hold on. So I think you can all see my screen. First of all, it's about, this year we started this talk series, and we've got the girl and a lot of speakers coming to talk to us and to share their expertise. Today has been Giant Kweku Asmah, and we really love it. But we want to invite you all. If you think that you got something to share, please let me know. And then, we'll give you the podium to speak, especially, those in the other fields that is not very common in terms of GSTS, in the finance area. And, there are some areas that we don't seem to, we don't seem to be there. So if you find yourself there, you want to share something, please let us know. The second thing is that, we UK group, we want to upgrade this clock, and we've got a clock in the school at the moment, but this very senior giants wanted us to have all the bells and whistles, so we've brought the controller back, because the controller didn't, it wouldn't give you the chimes. So we brought it back. I've actually sent it to the guy, and he's going to program some chimes in there. I think we're going to also have the GSTS anthem there, and also the national anthem. And but we need to have a separate discussion as to when those ones is to be played. And because he was asking, what time do you want these things to play? What time do you want, a national anthem to play? And so we need to have a separate discussion on that. So, but generally, if you want to speak on any topic, please let me know. So now we'll go to questions. So I think I'll hand over to Kweku, if you can put on your screen again. All right, Cici, you can unmute.
Hello.
Hello.
Hello, good evening.
Good evening.
Yeah, well done, Kweku. He's really given us a good insight to automation. I want to ask him a question. Kweku.
Yes, sir.
If I have a two-way gang, Kweku, you know me, we work a lot. If I have a two-way gang and I want to do automation, I've done this Alexa in my home, but I have a two-way gang that I want to use. But normally the two-way, it means one should go off, but I want the two all to work. But I don't want to buy two of the switches. How do I go about it?
Okay, so
do you understand my question?
I idea. You are using the those two switches to control one light, or what?
Yes, correct. I have a common
in a corridor.
In a corridor, yes. No, I was in my sitting room.
Okay.
But they come at both ends. So more or less, there's one from the bedroom, you get it switched on, or when you're coming from into the house, you get it switched on.
I get it.
But I want to get it automated.
You need two small devices. You need two small devices that would connect to a and they will hide behind the switches and get it done. So the two switches have to be converted to become smart switches, and we will fix two devices behind them and then connect them wirelessly to Alexa.
So I need to get two. I don't have to disconnect. I need to get two switches of the. I have to get two switches of the automation.
You can maintain your switches, but they need to currently the switches smart.
Okay. Okay. All right. Both should be smart. Okay. Thank you. Thank you. All right.
Let me guess.
I'll call you after 8. I want to do some.
Okay, Dr. Kwa.
I'll call you after.
All right.
All right.
Dr. Kwa, you can unmute.
Oh yeah, come on. Come on, man. Hey, this one's gonna be on me. Actually, you know what? No, it's still gonna be on you, that bags.
Yes.
That was a very good presentation. I have a contribution in a question. About 25 years ago, there was this petrol field in Norway, in the Norwegian part of the North Sea. It had it's basically a gas field, but there was an oil column, which was just 2 meters thick. It wasn't uniformly 2 meters. It varied. 2,000 meters. They had to drill a horizontal well through this. If they missed it by 1 meter, it would breach the reservoir. But what they wanted to do was to just produce the gas first, and then they'll go. The oil first. Then they'll go to the gas. It was supposed to be the most amazing engineering feat of the time. They did it 2,000 meters without touching it. It went through. It was automatic. Really amazing. Now my question is, if a factory, for instance, if an industry, an old industry, has a manual system, is it possible to convert it to automatic? Because I did vacation training at Boston Glass Factory. When they built it, at the onset, everything else is automatic except the batch. You mentioned the batch. That is what got me. The batch was manual, and at that time, the glass, the raw materials are sand, calcium carbonate, iron oxide, and some minor things, and they are calculated to 3 decimal places. So it had to be very, very accurate. When they started, they were using shovels, and the people on the floor said if they put in 5 shovels of sand, it came to a certain weight. 5 shovels of calcium carbonate, which was shells, it came to a certain weight. They continued until the shovels were about, with wear and tear, they were about half the size they started with, and they were still using it. So when we got there, we had to recalculate the batch and supervise it. But that was one of the reasons why our Boston Glass Factory failed, because over time they just went back to the old system. And when you do, because it is calculated to 3 decimal places, if you miss it by maybe 5 pounds, you are going to get rubbish glass. You have to break half of them. So if somebody if there's an old factory, for instance, like this one, is it possible to adapt and make it work? Is it possible?
Yes and no. So, the manufacturing process or the principle doesn't change. No. It is the drivers that would change. So, for example, if did you say silicon?
Yes.
Yeah. So if
silica, that's the science.
Yeah, silica has to be fine. It has to be in a hopper.
Yes.
A gate has to open. There should be a way of measuring what goes in. And typically we use this. I mean, Gassem is using something similar, where they have clinker and gypsum and all that. And then it goes from a hopper, opens onto a conveyor. The conveyor has a weightometer on it. So as it passes on the conveyor, the weight is being checked, and there's an integrator that converts all of that. So it is very possible to do this. I mean, it's not strange at all. It's something that can be done. You know, it's just about studying the principle and putting devices together. But you would need an actuator, you need a weight system, you need an integrator, you need a controller to stop and start it, and make sure your ratios or proportions are correct. And a lot of industries are using some systems like this.
Mm.
Yeah.
Thank you.
Richard. Richard, unmute.
Yeah, I think I'm on mute. Can
Okay.
you hear me?
Yeah.
Right. Thank you very much for this very enlightening subject. I've actually been very interested in this over the years. And I've been thinking that with all this knowledge, there are some basic manufacturing things that we do in Ghana that we can automate them. I recently saw a Chinese video in which they were showing how to crack open a cocoa pod, get all the various seeds out of it, dry them, and bag them. I mean, this thing that we've been doing this thing, this cocoa industry for a long time, but it's never come across our minds that we could do this thing. We could automate some of the systems. And I'm wondering whether we could start this thing at GSTs. Why don't we get some of these detectors to enhance our security, or the lights, to make sure that the lights can come on at the same time and goes off, because obviously we're paying for it. And if we say it's lights out completely. I mean, some of these little knowledge that we have, we could start up with the school, get some of these things automated, maybe the library, get the lights to go off and on. At a certain time, those at the entrance, the security guards, they can sit there, but they can hear when somebody's jumping over the wall, something like that. And start using this knowledge that we have to help the school. That's basically what I want to say.
Yeah.
Can that be done, though?
Oh, it can be done. It can be done. Raymond.
Is it going to cost us?
I think, yeah. Jan Kweku Asmah is already using his, he's going to crack his brain sorting out that clock and putting the horn up there. So, you know, he's doing quite a bit. So we'll come back to the detectors and the monitors later on.
No. Well, what I'm saying, Ray, is that we employ some of these ideas that this is elaborated here this evening, and try to think of a way by which we can come out and help the school by designing these things ourselves. We can do it. The detectors are all over the place, and where we see that we can use these things to help the security of the place. Yeah, we can.
Yeah, true.
Anyway,
Thanks
a lot. Anyway.
Yeah, thanks. Tete.
Yes, good evening, or good evening, I guess, right? Good evening, Jan Asmah. Thank you for the talk. I have a question about employment. Usually when new technologies like this come on board, one of the things that people are concerned about is it's going to take out workers, right? Because it's mostly automated. We also know that it usually brings on the need for new skill. In your experience, what do you think it is? Is it a net loss of jobs or a net gain of jobs? Or do you think we need, in Ghana, for example, do we need new people to retrain? What is your experience in terms of getting the talent and the people you need for this kind of work? And then I think to add to Giant in a way to what Jan Richard asked, how can we train our young ones, our GSTS, to be able to get into this new world of automation? Thanks.
Thank you. So for the skill issue, we don't readily have the young people with a skill. I found myself being the only company in Ghana trying to do this. And at some point, as we grew bigger and bigger, it got to the point where I had to start what I call Automation Academy. So I go to KNUST and talk to the students and get some of them to agree to undertake national service with us. And then we train them for the whole 1 year. It's all training. And then we employ them after school. And that is how we have survived. But we are unable to find people with a kind of skill we need to do what we are doing. If you take Ghana as a country and the rest of the world, I would say we are about 20 years behind, because there are so many people out there. If you placed an advert for an instrumentation or an automation engineer in Germany, for example, I mean, you would get very highly qualified people to apply. But if you did that in Ghana, you would find people with no experience at all applying to something that they have no idea about. So it's a bigger issue. It's a systemic failure in our education that I think we are not following the trend around the world. So we lack that. But we have trained a number of people. I mean, most of the industries have some of the national service guys who we trained out there. So back into the second question, I think we can start an initiative. I'm not sure how, but at GSTS, for example, if it is possible, we can start something there. I have started something on the site, small something for primary and JSS in my neighborhood, where we train students on electronics and coding and stuff like that. But as a whole, we have a problem. I go to the technical universities to talk to them every now and then, but it's you interview 50 students and you can't find anybody. So it's a problem. It's a problem. It's a problem.
So if someone said they wanted to start electronics and something as part of the technical education, you would advise that we go ahead, right, at GSTS?
Of course.
Yeah. Okay.
Of course, I'll readily support the idea.
Okay. All right. Thank you.
So maybe we can also open an automation club, controls, robotics club, and
robotics club.
Yeah.
Yep.
Yes, I think that's the way to go, really.
Yeah.
Hey, thank Kweku.
Yes, sir.
This is not Kofi. So based on what you said, then it's not a problem. I see it as an opportunity for people to get into that area. Am I right? Because if we are looking at it as a problem, then it's like, oh, but I see it as an opportunity for people to get into it. So I think the ideas you have outlined are awesome, and we can try some of them.
Yes,
I believe.
you are right. You are right in saying that there's an opportunity, but the fact remains that Ghana has a big problem.
I see. Okay, I see your point.
Cool. Frank.
Can you hear me?
Yes.
Okay.
But we can't see you.
No.
Okay.
Thank you, Asmah, for this this talk. It has brought back a few memories my sea days where a lot of there has been a lot of evolution on the processes on the ships, you know. And I just wanted to find out if you did only electronic controls or you do pneumatics as well.
No, we don't do pneumatics as a major. When especially on packaging systems, if we are working on packaging machines and there's a need to do pneumatics, yes, but it's not our main area.
Okay, okay. That is I mean, that's acceptable because everything is now going electronic and pneumatics has its drawback. Yeah. Exactly. Now, with this proposal that has been dropped by Richard, that we start this educating the young ones from GSTS just to point them in the right direction, you know, to see if we can get more automation engineers out there and sort of make the industry very popular. And in that way, it will make our lives easier. Because as they say, automation makes our lives easier, but in the end, it makes us not think. You know, all the thinking is done for us by the machines. And someone once commented, and I tended to agree with him, that now, if you ask someone to recite the 12 times table, most young guys will not be able to recite it because they have the calculator, you know. Yeah. It has its strengths and weaknesses, you know, but with the introduction of this automation at a lower level, that's in GSTS, I think it will sort of bring back those memories where we had hobby clubs, you know, where we could build things with our hands. Remodeling, I remember those days, you know, French club. I mean, we had a whole lot of hobbies going on, and on Saturdays and after classes, we used to do these things. So I would like to encourage you to sort of put down some sort of basics in place for these guys to sort of encourage them to do what they have to do, and just open their eyes to what they have been blind to all these years. Thank you so much for all this. All right.
Thank you.
Thank you. So are you saying you are the in Ghana, you are just one of the major automation companies, right? And they are not that many.
Yeah. There are a few of them now, but yeah.
Because when in your talk you said that one of the basic things in terms of automation is is to have a motor, have a motor that will drive fans and all that. Is there any reason why Ghana we are not producing motors? Because if you have a motor, I'm sure you get all these boys. If it's cheap, they can put a blade on it, and then they will have a mower. The mower can mow the lawn for them, and that's a home automation for you. And somebody can develop from just having a motor. You can develop a lot of things. So, in my opinion, we should really start from the basic and build up. Is there any reason why there's no company producing motors? Made in Ghana goods.
There are several
reasons.
There are several reasons why people are not producing certain things in Ghana, and simply about the competition out there. So I started manufacturing some of the things that we now import. Because I thought that it was the way to go, making it here. But you end up paying so much taxes at the port that you cannot compete with the imported products. So the fundamentals are not right, in my opinion, to be able to be a net manufacturer. The fundamentals are not right. So the issue of MOA, for example, there's no drive to ensure that we remain green. Everybody is tiling everywhere, so nobody has any lawn. So there's no attraction for a MOA.
Okay, okay. I didn't even look at it that way. Okay.
So there's something we are not getting right as a nation. And I think that's one of the reasons why the market is not open for certain products to thrive. You know, so it's but I mean, everything it's the same human beings who would produce the motors here or in UK or in China, right?
Yeah.
But at the end of the day, the raw material must be available, and those in China obviously have some advantage if they're not paying the taxes that are supposed to. You know? So, for example, we build electrical cabinets. I'll use that as an example. We build electrical cabinets. When we build the cabinets, when we import the raw materials, which is the sheet steel and the contact and all of that, the we pay is higher than when somebody brings a completed panel from outside Ghana. All right. Oh yeah. So then there is no incentive to our value proposition is that when you order, we can build it for you in 2 weeks.
Yeah.
If you order from overseas, it probably will come after 6 weeks or 8 weeks. But other than that, we are more expensive than the imported one. And the only reason is that we pay in over 40% import duty. That's it.
Yeah.
So if you are not encouraged, if you don't have the passion to do it, you would forget about it and import it. That's basically what it is. Yeah.
Ray, can I come in here, please?
Yes.
Yeah. This question has drawn my attention to some experiences I had. You know, went to Bangladesh, India, China. I mean, and all these motors and fans were being backyard factories. You know, somebody's house. They start producing things. You know, and I think because of the numbers, you know, they could manufacture these things, and the market was there. You know, but unfortunately, with in Ghana, we haven't been able to market ourselves properly, or even go as far as ECOWAS or the whole Africa to market our product. Because I believe when you factor in the overheads, after a while, you'll be able to, if you have enough exports, you'll be able to recoup any losses you have made and start making profits. You know, but the problem is marketing of our own stuff. And that sometimes becomes difficult, because when you start something and it's of good quality and you're able to market it, I mean, inside and outside the country or outside the continent, I think you'll be in business. So I think we will have to look at the marketing aspect of it, not only the manufacturing, you know, because it's always when you manufacture the goods, you have to find an outlet to let them go, and you make some of your money back, or if not all, you know. So I think marketing has been our main problem. Some years ago, when I was in Nigeria, I had a discussion with their shipping company, and they were thinking of buying new ships. And I told them that, look here, if you buy new ships, where are you going to send the cargo? You have to sort of open up, you know, so that you'll be able to go everywhere. And I mean, bring goods from other parts of Africa. If there are other shipping companies outside, they will also come and take goods from it. And with the trade, the market is open, and everyone wins, you know. But somehow our mentality is that, oh, I'm the only person who wants to make the money, you know. So it becomes difficult, but we have to look at marketing before we think about mass production. Thank you.
Thank you. Dr. Kwa, make it short, please.
Yes. Frank, it's not marketing. Like our brother is saying, the Chinese, everybody patronized. They all started like that, but there was a conscious government effort to patronize local products. I mean, an individual has created things. Everybody, even almighty America, they look inward and stop exports from other people when they have products. The only way we can move forward and start producing things locally is to ban the renewable nonsense, all the junk that people are flooding our country with. Like our brother is saying, if it's created motors, yeah, initially it might be expensive, but as people buy, as more and more people buy, it will come down. But if now he has packed it up because we didn't patronize it, and we're getting junk from outside, which is creating environmental problem. We have to make a conscious government effort to get Ghanaians to patronize locally manufactured things. If about the late 60s, an old giant, created an MRI scan at the Atomic Energy Commission. He built everything from scratch, including the motor. When I came to the UK and I had to use one, I said, what? This is exactly what this giant had produced. 1969. He built it in 1969 because Reverend Professor Gabra brought the prototype from Russia, and this guy sat down and designed it and built it from scratch. But what happened? It wasn't patronized, so it collapsed. So we need a conscious government effort to support people like our brother. Otherwise, we are not getting anywhere. Thank you.
Okay. Thank you. Thank you. Thank you very much, Jan.
Great. Let's chip in this. And there's a wave. You know, Nigeria shut their borders last year. And it was exactly to drive the locals to patronize made in Nigeria goods. It's as simple as that.
Yes, that's simple as that.
Working. And for me, it's you see, market forces will just take their level.
Yeah.
One, you need the product. There's a need. All right. So if we are able to encourage the locals, definitely make the opportunities available, get the market ready, it would work. But if government does not step in, there is really no way. Government is interested in taking import duties.
Yes.
But at the end of the day, it's not sustainable.
No.
Because, you know, at the end of the day, all the other countries, are you talking about Nigeria, Indonesia and India and all of these places, even South Africa, you cannot just get up and say, I'm importing a vehicle into the country. There are rules and regulations. So made in South African cars are what the locals are supposed to patronize. You know, so it's really a direction that we've taken that is not right. And I think that's what's affecting us. We go through a lot of problems with the business we run here. It's terrible, but you know, that's what we've chosen to do. So for me, it's really a government-driven thing. We need to be encouraged, and the direction must be right. Otherwise, an individual cannot, it doesn't matter how much marketing you do, if your price is not competitive, nobody would buy your product.
Yes.
Yeah. Okay. Thank you. Thank you so much. Yeah, I think we would close now, unless anybody has got anything else to say. But thank you very much again, Jan Kweku. Thank you, especially that, you know, I said, can you give us a talk? And you say yes right away. No
hesitation.
No intro, you know, which is good, you know.
Hey, Ray.
Yes.
Yeah, just wanted to thank Kweku Asmah for this wonderful talk. I had an engagement. I came in late, but I know Kweku so well, and I know what he stands for. He's doing so much. I was in Ghana 3 months ago. I went to his office. A giant friend of ours who is a safety expert. He had contracted him to train his guys. And I mean, of course, I know that giant got the job, not because he's a giant, because he's also on top of what he's doing. And it's so beautiful. Kweku has done a lot for the country.
Yeah.
And continues to. The last batch one time I was in Ghana, his company had retrofitted Ghana Institution of Engineers building with, how do you call it, solar panels. It was incredible.
That's nice. That's nice.
He donated to Ghana Institution of Engineers.
Yeah.
Well done. Keep on doing the great things that we are proud of you.
Yeah.
Good to see you.
Yeah. Thank you, Kweku. Thanks.
Talking about solar panels, GSTS needs some.
Yeah, they have to put their hand in their pocket, you know.
No, so we have to sit down and work out how we can build it for them, get the infrastructure there for them. I mean, these things is within our capabilities. There are things that we can think about. Laying off the panels and so on and so forth, the batteries and so on. We can think about these things, but again,
But thank you very much, Kweku. And thank you very much again, those who have joined us from Ghana and the US and Europe, and also the UK as well. You've done well. So thanks. I think officially I'll turn the recording off, and then you can stay on and we can have a chit chat. But formally we are closed.
Thank you.